So today we are introducing this library called Pandas. So Pandas is a very interesting library that you can actually use to manipulate your data, to do some data analysis. So basically, data analysis is done, mostly done. I think I can say 90% done in Pandas. So Pandas is just an acronym. It's just panel data. So it's like the way you are describing data, getting actually insights from that data. So Pandas is most especially dealing with data manipulation, pre-processing, and filtering, and other sorts. So the screen that you're looking is called Jupyter Lab. It's different from Jupyter Notebook, but not necessarily different because in this Jupyter Lab is where you can actually have some other functionalities to do with threading and whatsoever. So what you're seeing here is the same way. It's going to be the same way with Jupyter Notebook. So if you have installed Jupyter Anaconda distribution, it's you have Jupyter Lab installed. So let's get started. So I'll create a new notebook, and this new notebook, I'll just say maybe, so you have to select the kernel. So basically it's Python 3. If you have Python 2, you have to select here on this drop down, but I do have Python 3 as my kernel or the engine that is going to run my code, that is going to run to actually to execute the code. So I'll select this kernel and let me rename my file. So I just right click by placing on the file and rename this file as intro to Pandas. And click enter. Once I'm done, I'll get back to this code, to this section right here that I'll write my code. So first of all, we need to import libraries. Import libraries. So these libraries are going to import two libraries. The first library is going to be NumPy. When we are working with Pandas. So now build on top of NumPy. So the way we were dealing with NumPy with my dimension arrays and whatsoever, Pandas is built on top of NumPy, but however, instead of dealing with numbers, arrays, and whatsoever, what we are trying to do is putting in some little bit of information, for example, like in Excel. So it's like you are just adding your own information and manipulating and so forth. So that's why we are dealing with NumPy, and there are lots of calculations that are available on there. But we are putting NumPy here so that we can actually produce some arrays to work on this list as fast as possible. So the first part of this course, I am just teaching you how you can work around in Pandas. And then the second part, I'll actually teach you how to work with real data that is available out there. So we have two courses here, and these courses will get you up and running as soon as possible. So the next library we are putting here is Pandas as PD. Just like that, and click Shift Enter. It will execute, and it's done. If you can see that there's no asterisk here, it's done executing. Now, why are we dealing with Pandas? So Pandas is an open source library that is built on top of NumPy. And it also allows for fast analysis and data cleaning and preparation, as already said. And it excels in performance and productivity. I can give an example of Excel. Most companies in Malawi, they tend to use Excel, but Excel is limited to 1 million rows of data. So meaning to say, if you are dealing maybe on a national level, which individual data is almost it's over 1 million, you cannot do that. That's why you tend to work with pandas in order to deal with more than 1 million data points. So if you are working maybe in hospitals or in sorts of that, you need to make sure that you are using pandas so that you can handle vast amounts of data. And also it has built-in visualization features, so you can actually do some data visualization with pandas and whatnot. And it can work with data from wide variable of sources. So you work with different data sets on this library. So let us actually create a series in pandas. So a series is just like a list, but however, you can do indexing and whatnot. So in order to create a series, let us just create labels here. And on the labels, let's put label A, B, and C. The way we were doing in our previous Python course. So let us put data that we want to indicate here. So let's say my data is equal to, we're just creating list basically. So let's put here 10 and 20 and 30. Just like this, and let's create an array. So an array, it's to create an array, we use the NumPy library. So we put np.array, and you actually place in the my data list so that we can invoke it to become an array. So that's what we are doing so far. So we are invoking it to become an array in this case. And the next part is we actually need to create a dictionary. So a dictionary is we just put it to a variable called D, and let's create a dictionary with A and with 10 here, so that we can differentiate between a dictionary and a series. And let's put B, and here 20 to C here, and 30. Let's close the dictionary and click on click on Shift Enter to execute the code that we're working with. And let us check the labels if we have actually created them correctly. And let us check my data list. Click Shift Enter, and you can see that we do have our list available right here. And also let us check the array. Yeah, the array is created, and the dictionary. And yes, we do have the dictionary created, so we are good to go. Now let us create a series in pandas. So in this case, in a series, you can take it as a column and different rows, the same as in Microsoft Excel. But we do have a simplicity, and we can also do some advanced calculation on those series. So pandas actually give you the ability to create this series as fast as possible with a simple line of code. So for example, if we say PD, so remember we have imported pandas as PD at the top here. If you can check, we have imported pandas as PD. So in order to get access to the methods of pandas, we need to explicitly say PD dot. And here, pandas has got lots of methods. If you can click Shift Enter, you can see you have lots of documentation here that are available. And if we press Tab, there are lots of methods that we can use in order to actually deal with the data that we are working with. So these are different methods, but we are not going to go we are not going to actually deal with this all of these methods, but you can check them out in your own time and to see how these methods are helping you. But we are concerned with a series method. So a series, it's a series method. We can use it to invoke or to explicitly convert our array or our list into a Pandas series. So if we say series here, since it's a method, you actually need to put open and close brackets. If we click Shift Enter here to get the documentation, there is something here that you need to get, you need to know. First of all, our first parameter is going to be data. So in this case, the data is the array or is the array or the list that you need to convert in order to go to the series. The index you need you also need to put in. If you want to put you on specific labels, we'll get in touch. You can also explicitly say the data type or the name, or you can actually copy or do fast path. Those areas we are not going to reach them. But in our case, what we need to do, the first parameter is called data. Then we'll say is equal to my data. Just like this. If we click Shift Enter, you can see that Pandas has actually converted my data, and my data is a list here, and has converted to a series and with indexing. So what's the purpose of doing list, doing series like this, converting list to indices, to series, I mean? You have the power of indexing. So this indexing can help you to analyze the data or to do a lot of calculations. And also you can use it to find the data in your data frame. We'll take a look at that later on. So, however, we have seen that we also do have indexing in this as a parameter in this method called series. So if we say pd dot series and put say data here is equal to my data and comma to separate and put the index is equal to labels. Remember, we do have labels here. So before I execute that line of code, if we go upwards here, I do have labels called A, B, C, A, B, and C. So I have explicitly say that my index is going to be labels. So instead of having 0, 1, and 2, I can just put, say, I want maybe index to be my labels, or you can put names of countries, names of individuals. So if we click Shift Enter here, you can see that we have converted the index to be A, B, and C. So this is very important when you are actually assigning, for example, values to individuals or to items that you are working with. And you can do this as fast as possible. So because we have learned that any function in Python requires some of the functions requires parameters here. So you don't have to put data or indexing here because it can actually detect that when you put these parameters in a proper manner. So if I can say my data here and put comma index and close bracket just like this, you are going to get the same results. So let me see. No, I don't have to put index here. That's why you can say index is not defined. So I can just put labels here. And click Shift Enter, you get the same results. You don't have to do this, but this is a good practice when you want to troubleshoot your code later on in order to see what you're working in. So you can also convert arrays or NumPy arrays into series. So if we say pd dot series and convert them to arrays just like this, click Shift Enter, you can see that our array, which is above here, 10, 20, 30, it has been converted to series. So you can actually appreciate the power of pandas converting to cities. So you have converted them to cities as simple as straightforward. And the last time we talked about generating vast amount of arrays that we can generate vast amount of arrays, maybe of 20,000 values, and you can convert them to cities and work out the data analysis from there on. And because we can also assign this array, this cities of array to values, we can also do we can also assign them to labels. We can also put the labels parameter here and click shift enter, and we are good to go. We have actually converted the indexing from numerical values to characters, just like so. So Pandas also allows you to convert the dictionaries to cities. So you can see that it's very powerful in conversion, in working with the different data sets. So you don't have to panic when I am working with a data set. Maybe we have seen my data sets, for example, HDF, which Excel does not allow you to do so. You can work with maybe different, for example, no SQLs. You can work with HTML files. We can work these files. You can read these files maybe from online, Chanchan, or any GitHub or something, and Pandas can handle that, but not other softwares, for example, like Excel. That's where limit is. So if we put here, let's get back to this. If we put pd.cities, and in our method, let's put D. Remember, D is our dictionary, and we can also get these values. And if we go up here, you can see that our D is a dictionary, and we can convert that dictionary to a series, a pandas series. And Panda is very cool as well. And you can also convert cities to functions. You can keep functions inside the series. So if we say data and is equal to a list of functions, for example, we have sum, and we have print, and we have length here, just like so. If we place shift it, you can see that I have put the reference of those functions somewhere else. So if you have, maybe you are keeping functions, I don't know the use case of this thing, how you can apply it in your own liking, but maybe you have created your custom functions and you want to keep them in order to access them or to check which functions have you actually created. You can do so in Panda and keep them in a series and access them actually. So that's how powerful Pandas is. And you can create these lists right in that Pandas series method. You can create these series just like the way I'm doing this. So we can say pd.series, and let's put the value. So remember, we are accepting a list of values. So if I can say here, if I want to create a series, I need to put a list inside of this method. So I can say maybe 1, 2, 3, and 4, and let's put in names of individuals. So let's put here John, and Mary. And here, let's put what else? Let's put Rainafe, and let's put here wait, Shimwemwe. Okay, I think I need to actually place it in a proper way and close this plugin. So what we have done so far here, remember last time we talked about when you are creating, for example, a dimension array using a function, for example, like random number function generator, you need to match the list of columns and names and so just keep that in mind. Or otherwise, if you do that here, if you have a list of columns that are not aligned, Pandas is going to create a now value section. So keep that in mind in this place. So if I say here and click Shift Enter, you can see that I have generated a list. So why our index is having this letters called John, Mary, and Afenchimema, and our column is having this number. Remember that it's coming from here, where the series function starts with the data and indexing. So in this case, our data is these numbers and the index is these names right here. So that's how you can have these names. So our names are just values. They're just, our names are just indexes and the numbers are values, just like so. So let's assign this series to a variable. So let's just say series 1 is equal to variable here, and let's create series 2 and put this one to a variable. Okay, so I'll just change a little bit because I want to teach you how you can grab these values. So let me just change here. Let me just change it here to maybe Nancy, here to maybe load name, here to, okay, maybe Gphonia. Okay, let me execute that one. Now I want to actually show you how we can grab values inside this function, because if we go here and say series 1, it's the same thing. If we go here to series 2, it's similar thing that we have created so far here, that we do have the indexing and whatsoever. It's just simple stuff. Now I want to show you how we can grab these values depending on their indexes. So if I say series 1 right here and put the name of the index. So remember, my indexes are names, so they are strings. So I need to make sure that I have put here, for example, John in quotes, show that it's a string. And if I press Shift Enter, and I'm able to grab John's value, which is here, the number 1 right here. You can actually do so, test it you can actually do so to test it with other values right there. So let us actually see how we can add these functions. So actually there is a very wonderful feature that Python Pandas has. You can add these series together, but there is something else that I need to show you what happens. So this is a powerful thing. So if we say series 1 plus series 2, if I press Shift Enter, let's see what has happened. So first of all, NumPy has checked my series. So NumPy is very intelligent. It's able to align these values depending on their alphabetical letters. So you can see A, C, J, M, N, R, and it starts adding the values. So if there is no corresponding value between these functions, these series, it is going to create not a number. So meaning to say, it's adding, for example, if we say on enough, it's adding 3 plus like not a number variable. So the answer is going to be not a number. So basically that's how it's happening. But however, let's see on John. So John, it has got 1 and 1 right here. It has added, it's going to 2. And it's able to convert that to a float, because if you are doing, for example, division mathematics, you don't have to lose your numbers. So that's how Pandas, it's very intelligent. And if you are adding, for example, let's say on a company, you are working with a data set yapa company, so you want to add my salary earned from January to December. You just need to do this, series 1 and series 2, and it adds up and you get it. Or if you want to find the mean the mean, the standard deviation, you just add this. As long as the data sets are similar, you don't have to hustle around, and you can add as multiple series as possible. So anyway, that's the whole part of Pandas series, and that's how you can work out with Pandas series. So explore other areas of how you can actually find other functions to work out in series. But as for this course, this is all you need to know. So let's finish up with data frames in Pandas. So let me put this as a markdown. So let me just say data frames in Pandas. Now, data frames in Pandas are the same as worksheets in Microsoft Excel. But however, you have multiple functionalities, and you can pre-process your data, remove your data with ease. You don't have to hustle around. With a simple line of codes, you can work with vast amounts of data and manipulate them as fast as possible. So in order to view that, let me just say NumPy, from NumPy, from NumPy dot random and import rand n. So remember, this function is the one that we had last time, where we are actually getting random values from NumPy. So we're just generating random values, and it's like a multi-dimension array. So let me just say np dot random seed. So this is a new method. So I will tell you what this method is all about. So random seed dot seed. Here I will just place 101, just like this, execute. So what this function does is to make sure that the random values that we have here are similar to the random values that I do have. So you don't have to say, my values are kusiyana. We need to make sure that we are in the same category. So if I want to create a data frame, let me just put a variable here, df, as data frame. I need to just say pd dot data frame, and I'll put inside this data frame parameters. So if I press shift tab here, let's see the parameters of our data frame. So the first parameter is the data that I want to have. The second parameter is the index that I want to have. But however, there is something here, the columns. We didn't have that before on series, but we have this now. So the columns are the same as the columns that we have in Excel. So we can name them as soon as possible. So let's work on this one. So we can just use the land in function that we have actually code here, we have imported. And let us just say, let us create a dimension array 3x4. And here we need to put the index. So the index can be, for example, let me put here A and B, and we just need to make it simple in this section in order to get in touch with NumPy. So if we say get in touch with Pandas, if we do this, so what we have created here is the index, same as what we are doing in series. But however, there is another column that we need to add, and it's called the column. We need to add another parameter which is called the column. So we need to put here w, let me just say wx y z. Okay, now let's close it here. Now there is something that I want to show you here. Have you seen that the number of indexes are 5? Remember, because we have 5 rows here, so it matches here. The number of columns right here when we're generating our dimensional array is 4. So we do have 4 columns here. So if we click Shift Enter here. What we have done, we have created a data frame. And if we need to see the data frame here, DF, Shift Enter, we have generated a data frame. So what this data frame is all about. So this data frame right here is just a group of cities. So we have W cities, X cities, Y cities, and also do have A cities. So if on A cities, it's connected right here. So on A series, we have values like 2.7, 0.6, 0.9. On W series, we have 2.7, 0.6. So it's just a combination of series. That's what a data frame is all about. And that gives us power to select, to manipulate the series and whatnot. So if we want, for example, to select a data frame, what we need to do is, for example, we can just say use the bracket notation. The bracket notation. So you can just say df and put here w as a bracket notation. If we press Shift Enter here, we have actually selected our column right here. So it's the w column is selected when we use the bracket notation. Remember, the bracket notation is how we are selecting values in our math dimension arrays. So that's why we have this value right here. And to show you that this is just a series, combination of series, we can actually check the type. So we can just say df here, the type, for example, w. Okay, and let me close it. Click Shift Enter. You can see that it's called pandas.co.series.series. So it's just a bunch of series combined together. So we can actually take values, because if you are working, for example, with when we go to machine learning, if you want to train our data set, what we need to do, you don't need to use lots of data set as your target or features. You need to select the values, the column, and use it as a target, and the other things used as features. We'll take a look on that later on. So this is why Pandas is very important. It's at the center of machine learning and data science, because you can actually select values with ease and work on those values. So let's also check the type of our data frame, which is, for example, the type of data frame, which is basically the data frame. So that's why we have data frame right here. So we have pandas.co.frame.data frame. Here we have pandas.co.series.series. So that's how you can actually get in touch with, get to know the difference between a series and the pandas. So we are about to finish here, and I just want to show you that you can actually select the column using the dot notation. So using dot notation, so if we say df.w, Shift Enter, it's the same way as this. But however, this is not allowed when you're working with a big project. Why? Because Pandas has also methods. So if we say df and press dot and press tab, you can see that Pandas has got other methods here. So for example, if you are, let's say, you are, for example, data set that you are working has got a name, for example, called empty. So if you press empty, you're going to override this function and you're going to cause catastrophe to the data set that you're working. That's why the dot notation is not required here, because you can override these functions, these amazing functions that we'll actually see later on. So anyway, this is what I had for you in this session, and for the rest of the session, I'll actually send it on YouTube, and I'll premiere it, And on the other sections, we're going to learn about condition selections. We did conditional selections on NumPy, but we're also going to do conditional selections on Pandas. And we're also going to learn how to deal with multi-level indexing. So multi-level indexing is very important in data analysis, which is the biggest thing. We're also going to deal with missing data points, how we can actually play around with missing data points. We are going also to deal with group by statements. So group by statements are used in aggregating our functions, in getting insights and values out from our data sets. And we're also going to deal with merging, joining, or concatenation. So if you know MySQL or SQL, you actually know what it means when you say merging, joining, and concatenation. But Pandas also has got those features that you can join different values. And we're also going to deal with operations and how to get input data inside and output that data later on. And from that, we are going to deal with all the basic knowledge on Pandas. So anyway, it has been a pleasure teaching you these basic knowledge.